Now that we have our renders set up and working properly, let's go ahead and start defining some shaders on these objects. And to make things run a little bit faster while working on this look development, I've turned off a few options in our render settings. So if we go to the out context, under the Redshift ROP, under Redshift, and the System tab, I've turned off the automatic sampling here because that's quite slow, and we should only really use this when we think a render could be a final render, or if you just happen to have spare render time. And I've also gone to settings, actually global illumination, and I've turned off both primary and secondary GI engine just for now. So we have a bit of a noisier image here. We may need to turn up the settings if we aren't seeing the render and the shaders clearly enough, but we'll start with this for now. And we also don't need to see the actual texture on the environment light in the background. So let's go to our object context and find our RS light dome here. And then we can turn off enable background so that that image is no longer displayed on that environment dome light. And then one more optimization before we get into building the shaders. All of this motion blur is also going to slow down our render quite a bit. So let's go back to out context, Redshift ROP, and motion blur tab, and I'll just disable motion blur for now. Then we can minimize that render view and let's go set up our shaders. So we'll start by creating an RS material builder. We don't want to create the standard Houdini material builder. We need to create the RS version for Redshift. So drop that down there and let's call this RS creature metal. And I'm going to do just kind of an almost black, shiny metallic look on these creatures. Of course, feel free to design these shaders however you want and use your own artistic judgment for the general look of these things. But for my creatures, I just did something pretty basic on the material here. You can see we have this Redshift material node and then this RS material that has all of the material properties. And for this creature, I'm just going to switch this to HSV and give this an almost black color. And by default, this shader is already fully reflective, but we can turn up the roughness a bit just to blur those reflections to make it slightly more realistic and a bit more imperfect. In my case, I only did a very small amount of roughness here. And then we can go back to object context, go to the render creatures geometry object, and under the render tab, for the material, we'll just specify that matte/RS creature metal material there. And we can go back to our render view and select just this region that we're interested in and do a re-render of that to see what that looks like with our new material. And that's looking pretty cool. I'm happy with that. And like I said, this is probably the simplest shader of the bunch. The rocks and water and the terrain are going to be a little bit more complex on the material side. So I'll stop this render and then let's take a look at the rocks. So back in our test camera view here, I'm going to hit the lock and move this camera to look a bit closer at some of these rocks in the riverbed here. Looks like this is a good one to take a closer look at. And once again, back to the material context, and we'll create another RS material builder. I'll call this one RS Rocks, and dive inside there. And we can start by giving this kind of a sandy color. Maybe something like this. Looks like a reasonable color for those rocks. And we're going to modify this pure color with a bit of noise as well, but I'll just leave it for the moment. And because these rocks are in the riverbed here, I'm assuming they're a bit wet, so we do want them to be somewhat reflective, but I don't want them to be overly reflective, so I've turned that reflectivity weight down a bit. And we'll make this a little bit more rough to blur out those reflections. And then we can do a fresh render and see what this looks like. So I'll turn off the render region and kick off a new render here. And this doesn't look any different yet because we haven't assigned the shader. So back to the object context, go to our render rocks here. And then under the render tab, we'll point this to mat/rs rocks. And sometimes when we change these things, the change isn't picked up automatically by the Redshift render view here, so you may need to do a refresh to get it to show us the changes. So there we go, we have some nicer looking rocks now, but these could be made a little bit nicer, perhaps with some more breakup on this color, so it's not just one flat color for the entire surface. So I'll click this arrow to go back into the rocks there. I'll stop this render and minimize that. And then back inside the rocks, we can drop in a noise to use to break up this color here. Now I'm going to open up the drop down on the base properties here, and we're going to wire an input into the diffuse color. So I'll start by creating an RS color constant. And for this color constant value, I'm just going to copy this diffuse color. So right click, copy parameter, and I'll paste the values, not a relative reference. Paste values into this color constant. And I don't know if the alpha portion here is important for this scenario, but I'll just change that fourth value to 1 just to make sure. And then if we wire this out color into the material diffuse color, we should get no changes. Should be exactly the same as before, but let's start applying some noises as well. And this Maxon noise that comes with Redshift is pretty nice, so I'll use that. And then we're going to multiply this constant color value with a black and white noise here to kind of get some breakup on that color. So if you type mul for multiply, let's create an RS vector mul, and let's drop this on our color constant, and then multiply that by the noise. And let's bring up our render view so we can see this more clearly as we are tweaking it. I'm going to just pick this specific render region and restart this render. And right now we're on the shadowed side of this, so it might be a little bit harder to see. So I'm actually going to stop this render, and let's go back to our camera view here, and let's pan it around so we're on the sunny side of this rock. Might be a little bit easier to see the noise this way. And we'll restart that render once again. So now we have some nice color variation happening from that noise, and we can go back to our noise here and play around with all of the different types available to us. There are lots of noises that you can play with. This Booyah one is looking pretty cool, but for this color noise, we don't necessarily want a ton of detail in here. I just want some broad color variation on the surface. We'll get more detail in a moment out of the bump map. So for just some general color variation, I'm liking the blistered turbulence here. That works pretty well. And we can play around with the scale to match the object. So if we scale this up quite a bit, you'll get much larger noise shapes. And that's looking kind of strange, that large. Default is looking a lot better. We can play around with some smaller details. Like 0.5 is looking pretty cool, but I'm not really looking to get this much detail out of this color variation. So I'm going to leave this at its default scale of 1. And the darker areas are getting multiplied down almost all the way to black here. And I'm going to fix that by limiting the range on this Maxon noise. So instead of going from pure black to pure white, let's go to HSV, and I'll change the black to 0.2, white I'll turn down to 0.75, and this is making the color variation look a bit more natural. Now this is still looking, pretty artificial and very smooth, and we can rough this up some more to make it look a bit more realistic. So let's drag our redshift material down here, and you can see that has an input for a bump map. So I'll drop in an RS bump map and connect the out to that redshift material. Let's open up the texture inputs and create another Maxon noise, and connect the out color into the texture input. And by default, these bump maps are going to be extremely aggressive. You can see this is really visually messing up the look of these rocks here. So I've always found I need to turn down the bump map height quite a bit. Let's turn it down by at least 50% to start. You might want to leave the bump a bit higher than you'll ultimately want it while you're playing around with different noises, and then tone it down once you find one that you like. So once again, we can play around with the different options here. Blistered looks pretty cool. Cell noise just looks weird. Booyah's pretty nice. Luca's quite nice. I think I'll stick with the Booyah here. And we'll just test out what scale we want this to be. So I'll try scaling this up quite a bit. That's looking a little bit strange. Let's go back down. I actually quite like how this one looks at its default scale of 1 here. So let's try toning down the height on the bump map to see how that looks. Looks like 0.01 is starting to get too subtle, and of course, as you progress with the project and do more rendering, you can tweak this as we go. But for now, I'm going to leave this height scale at 0.1 because I think that's looking pretty decent. And next, we're going to do the shading on the environment. So I'll stop this render now. Let's lock the camera and the viewport once again, and move our camera to somewhere where we can get a better look at the terrain. Now back in the material context, I'm going to just create a copy of the rock shader, and I'll call this RS-ENV. And back on our rendering objects, go to render ENV, and let's assign that shader mat/RS-ENV, and dive inside that shader there. And let's do an initial render to see what this looks like. So for this environment, we're going to have to pump up the bump map a bit more. So let's try turning that height scale up to something like 3. I'm going to zoom in a bit closer because I'm not seeing the detail very well from this distance. And for now, I'm just going to take the noise multiplier off of the color as well, just so that we can get a better look at one component of the shader at a time. So I'll just wire this constant directly into the diffuse color. That's brightening this up quite a bit. I do like the terrain to be a bit brighter than the rocks, so we may leave off this noise multiplier entirely, or we can keep this connected and just change the noise ranges. So let's, instead of going from 0.2 to 0.75, let's keep the maximum at 1 and change the 0.2 to something like 0.7. We'll try that just for some more subtle variations, or even 8. Maybe I'll turn up the overall scale to be 10 times for some even more broad noise color variations. And then back on the bump map here, we can play around with some different options. I'm not really seeing any bump detail yet on this terrain here, so we may need to turn this up quite a bit. I'll turn the noise scale up to 10, so hopefully we can start seeing that detail better. And there we go. Now we're starting to see some interesting bump on this terrain. But I don't really like the Booyah for this. I can play around with some other options. Displaced turbulence is cool, but that doesn't look very natural. Luca's alright. The one I ultimately settled on for this, though, was Gaseous. So this looks pretty interesting to me. I quite like the look of that. This is far too much bump height, though, so now that I found an interesting pattern that I like, I'll just turn this down a little bit. Let's take that down to 0.3, and now this terrain is starting to look pretty cool. And the general surface of the terrain is looking pretty nice so far, but we may want this to look a bit different inside this riverbed area. It can be quite nice to perhaps darken the terrain a little bit more as it gets closer to the water here, and having a darker terrain underneath the water will help to contribute to the look of the water itself as well. So for the moment, I'm going to turn off the water entirely. So let's go back to our Redshift ROP, go to the objects, and sometimes to just turn off objects, instead of removing them from the list, I often like to just put an X in front of the object name, because xRender_water does not exist, and that object will no longer be included. And it's just easy to get rid of that X when we want to bring the water back. And I suppose we could also turn off the rocks as well, so we can get a better look at what exactly this terrain is doing in this riverbed area. So let's refresh that render, and we have our mask attribute that still exists on this geometry, and we can use that mask attribute in this riverbed area to affect the shading parameters. So let's go back to material context and go inside our RSENV shader here. And actually, if we go back to the render object for the environment here, we can middle mouse on this object merge, and you'll see that this mask attribute that's in that riverbed area is a point attribute. So then back in the shader, we can use an RS point attribute to look up that mask. So let's change the attribute name to mask. And just to test this out, we can wire this out color here into the diffuse color directly. And this doesn't look like it's having an obvious effect yet. We may need to refresh this for that mask attribute to be included here. There we go. Okay, cool. With that refresh, we can now see this gradual fall off from that mask attribute, and we can remap this white to black, that 0 to 1 value of this mask, to drive a few different parameters. So to remap this, we can use an RS change range, and we'll connect our mask input. Let's rename this to mask for clarity. Connect that color into the change range input. And we might want this to be reflective in this riverbed area because it's wet, and then not reflective outside of this area, or maybe just subtly reflective. So we can say that when the mask attribute is 0, this new value is going to be perhaps 0.145, and we'll use that to represent the reflectivity of the terrain outside of the riverbed. And then when this mask attribute is perhaps a value of 0.3, this will be fully reflective. So remapping this from 0 to 0.3 makes this reflection change happen only in a limited range here. So we get a value of 0.145 up here, and full reflectivity of 1 down here. So then we can connect this output to the reflection weight. You can see it's no longer very reflective up top. And then we can do something similar for the reflection roughness. So we can just copy this change range here. Just do a copy paste on that. Let's get our bumps out of the way here. And on this new remap, we can perhaps leave the 0 to 0.3 range alone, and we can define the roughness when the mask is 0 as something fairly rough and diffuse, like a value of 0.8, and when the mask is 0.3 or higher inside the riverbed here, we can turn the roughness completely off by setting it to 0 so that we get some pretty sharp reflections. And then we can wire this output into this reflection roughness here. And then finally, we can modify the actual color as well. So before we had set up this RS color constant with a multiplier, and as an alternative to using a multiplier to change the color, we can also do a color blend instead. So let's drop in an RS color mix, and we can connect our original multiplied color to the first input, and we can use our mask attribute attached to the mix amount to control the blend. And then on this color mix, for the moment, I'll just change the second input to be totally black so that we can see what this looks like before we start dialing that in. And connect the color mix out color to the diffuse color. And you can see now we have this darkened area inside the riverbed here. And of course, if you want to change the fall off of that color, we can do another change range to remap this. So if you want this to transition over a much more limited range, like have this color just ramp up in this short space here, then we could perhaps change the old range min and max to go from 0 to 0.1, or actually it looks like that puts the transition up here, not there. And then we can also adjust the new range min and max to control that blend a little bit more. So 0.3 and 8 will make this not go all the way to black inside the river, and it won't be quite fully colored outside of the river either. And of course we can add some more noises to break this up some more. Perhaps just drop in another max on noise, and instead of blending this to black on this color mix, we can connect an additional noise to that color mix input here. Maybe try some blistered turbulence. Maybe make this large scale just for some broad color breakup. So you can see we now have some color variation inside the riverbed, and we can reapply some darkening inside the riverbed there by adding another RS mul. And we can once again remap our mask attribute to multiply down that noise, and you can, apply as many different remaps and noises and etc. as you want to kind of just break up some of these more plain features and add some more real world variation to this. So by adding that noise and then multiplying that down by the inverted mask, we're kind of, just getting a little bit more of a natural breakup of color inside there. And we can also add ramps into the noise color inputs as well. So perhaps take another remap range, and then we can pipe that into one of the noise colors here, so that the color blend in this noise is based on that mask attribute as well. So clearly you can spend quite a while playing around with different noises and attributes and remaps and etc. So I highly encourage you to experiment with this and play around with some cool variations on the shader looks. And now that I'm pretty happy with the look of this terrain here, I'm going to stop that render, go back to the out context, and I'll bring back the water and the rocks. And finally, let's add a shader to the water. So now back in the material context, let's create another RS material builder, and we'll call this RS underscore water, and dive inside that. And we'll start just by turning the diffuse weight on this all the way down to 0, and go down to the refraction and transmission, and turn this transparency weight all the way up to 1. And you can see that the index of refraction here is grayed out because it's currently linked to the reflection. So we can go up here to the reflection index of refraction and change this to 1.33, which is the real world refraction index for water. And then we can run a new render and see how this looks. Of course, it doesn't look like anything yet because we haven't actually assigned our material, as I keep forgetting to do. So back on our render water object, assign the RS water, and now this is starting to look pretty interesting and realistic. Now currently, this water is starting to look nice, but it's a bit too see-through. This might be a little bit more obvious if we perhaps zoom in on some of these closer areas here. You might be able to see how this is looking, perhaps a little bit too perfectly see-through. And we want this water to be a bit murkier. So in Redshift, I generally do this with the subsurface settings here. This transmittance color will essentially pick up some color as the rays travel through the surface. And I'm going to set this transmittance color to the same base color that we're using for the environment. So I'll set this to 0.76, 0.7, 0.5. And you can see this is starting to look really thick and murky and swampy. And this looks pretty interesting and looks pretty cool, but it's kind of too extreme for us. So let's turn down the absorption scale to something a little bit less thick and opaque. And you can also bring in the scattering if you want. That will pick up this scatter color here. And this is starting to look really kind of milky as we turn this up. So we probably don't want to push that too much, but you could try bringing in just a little bit of that if you'd like. And I think just this tiny bit of scatter scale, this 0.03 here, looks a little bit nicer to me than when that's completely off like this. And now this phase here refers to what direction the light is bounced when it's scattered. So a positive phase value means that when a light ray enters this object, it's going to get scattered in the direction that it was already traveling. Whereas a negative phase value means that light ray is going to get bounced back toward its source. And in this particular case, it's not a major component to the look of this water, but I've set it to minus 0.3 for a little bit of backscattering based on whatever particulates and such might be in some natural water like this. And now that we've added shaders to all of these objects, I've turned global illumination back on for some better lighting, and things are starting to look pretty nice now that they have some proper shaders applied.